Over 90% of the world's most advanced chips, the brains in our iPhones, PCs, and AI servers, are made by one company in Taiwan. That company, TSMC, also controls roughly 60% of the global chip foundry market, meaning more than half of all the chips designers dream up end up fabbed in TSMC's facilities. Even Intel, the legendary pioneer of Silicon Valley, has had to rely on TSMC for some of its cutting-edge chips. This raises a billion-dollar question. How on earth can Intel hope to beat TSMC without just building better factories? Intel's new strategy to challenge TSMC isn't about one-upping them in pure manufacturing technology, at least not only that. Instead, Intel is attempting something different and arguably more ambitious, building an open ecosystem that can rival TSMC's tightly knit walled garden. But what does that actually mean? How is an ecosystem going to help Intel compete against a company with unmatched chip-making prowess? And can this strategy really work, or is it too late? These are the questions we'll explore, from the history that got us here to the coalition Intel is assembling, the economic logic behind it, and the risks that could still derail the plan. TSMC, Taiwan Semiconductor Manufacturing Company, is the world's dominant semiconductor foundry. In plain English, TSMC is the factory for hire that builds chips for countless other companies. If you're Apple, Nvidia, AMD, Qualcomm, or almost any major chip designer without your own fabs, you go to TSMC. Over the decades, TSMC has constructed what you might call a walled garden for chip production. Inside its walls, TSMC offers a one-stop shop, cutting-edge manufacturing, packaging technologies, and a robust support network of materials and EDA tool vendors. It's an ecosystem, yes, but one largely controlled by TSMC itself, ensuring that once you're in, you have little reason or ability to leave. One key to TSMC's success has been trust and cooperation across the entire semiconductor value chain. As one industry expert put it, TSMC has an ecosystem built on ironclad trust and tight cooperation from design to equipment to actual production. This was by design. Founder Morris Chang knew that to win business, TSMC had to be a neutral partner that never competes with its customers. Unlike Intel, which historically designed and made its own chips, TSMC promised to only manufacture others' designs. This neutrality became a cornerstone of TSMC's walled garden. Companies could hand their crown jewel chip designs to TSMC without fear that TSMC would use that IP to make rival products. That ironclad trust, coupled with tight integration with partners, from EDA software makers to equipment suppliers like ASML, allowed a large group of companies to act as a team to build a world-beating chip-making operation. Inside TSMC's garden, customers also benefit from an extensive library of pre-certified IP blocks, pre-designed circuit components, and close collaboration with design tool vendors. TSMC's Open Innovation Platform, despite the name, it's part of TSMC's curated ecosystem, provides thousands of ready-made design components and reference design flows that are guaranteed to work on TSMC's processes. In practice, this means if you need a USB controller or a memory module for your chip, you can license one that's proven on TSMC silicon. Need design software to lay out your chip? TSMC has co-developed reference flows with the top EDA tool companies like Cadence and Synopsys to make sure those tools play nicely with its manufacturing process. All of this creates lock-in. The more you build around TSMC's ecosystem, the harder it is to switch to a different foundry. It's comfortable and well supported, but also a bit like a walled garden where TSMC tends the only exit. TSMC's dominance is self-reinforcing. Because it runs at such massive scale and high yield, its manufacturing costs per chip stay low, and it can afford to pour over $30 billion a year into staying ahead technologically. Today, TSMC's market share has risen above 60%, and it commands an astounding 90% share of advanced chip manufacturing at nodes like 5 nanometers, 3 nanometers, and soon 2 nanometers. That scale attracts the biggest, richest customers, notably Apple, which alone contributes around a quarter of TSMC's revenue. In fact, analysts estimate Apple might spend as much as $60 billion on TSMC chips in 2025, an order potentially larger than Intel's entire annual revenue. When one customer's order can eclipse the sales of your whole company, you know the playing field is skewed. TSMC's huge customers also get VIP treatment. Apple, for example, gets first dibs on new technologies like 3 nanometers and 2 nanometers, essentially prepaying TSMC to build out capacity that Apple will then fully utilize. This symbiotic relationship makes it extremely hard for any newcomer to lure those big fish away. Why would Apple or Nvidia jump to Intel's nascent foundry services when TSMC delivers like clockwork and has every incentive to keep them happy? Yet, for all its openness to fabless customers, TSMC's ecosystem can feel closed in other ways. Its most advanced packaging technologies, like CoWoS or InFO, are largely in-house, meaning if you want the cutting-edge way to connect chips together or stack memory on logic, you often have to get it done at TSMC. And while TSMC collaborates widely, it keeps the critical details of its processes proprietary. It's not in the business of sharing those secrets openly. In short, TSMC's model gives customers access to the world's best chip tech, but on TSMC's terms. It's a golden cage for the industry, extremely attractive and secure, but ultimately under one company's control. So where does that leave Intel? For years, Intel watched the rise of TSMC's foundry model from the sidelines. Intel's identity was an IDM, integrated device manufacturer, design and manufacturing under one roof, a completely different approach. That worked brilliantly in the PC era, when Intel's x86 chips reigned supreme, and it didn't need anyone else. But as TSMC's open-for-all foundry model enabled the fabless revolution, countless companies innovating in chip design without having fabs, Intel's isolated garden started to wither. The result? Intel fell behind in manufacturing process leadership and missed out on producing chips for the mobile and graphics booms that TSMC seized. Now, with Intel on the back foot and TSMC the giant, Intel can't count on business as usual. It needs a way to counter TSMC's huge ecosystem of partners and customers, which brings us to the new strategy under its current leadership. In early 2025, Intel shocked the industry by naming Lip-Bu Tan as its new CEO. Tan is not a typical Intel leader. He's a 40-year industry veteran best known for connecting the chip world's dots. As the former CEO of Cadence, a top EDA tools company, and a longtime venture capitalist, Lip-Bu Tan built a Rolodex spanning every corner of semiconductors. Lip-Bu's Rolodex is like nobody else's in the semiconductor industry, noted Intel's CFO, after Tan managed to meet 22 potential customers and partners in a single day. In a way, Intel hired Tan precisely for his ecosystem-building chops. He knows the importance of bringing partners together, and he's respected by the fabless community that Intel now desperately needs to court. Tan's pitch can be summed up in one word: openness. In one of his first keynotes as CEO at Intel's Foundry Direct Connect event in April 2025, he told the audience of chip designers and partners, "We need to do a better job, make it easier for all of you to use our technology. We will rapidly embrace industry standards, EDA tools, and best design practices." This is a remarkable shift in tone for Intel. Historically, Intel was famous, or infamous, for using mostly internal proprietary tools and processes fine-tuned for its own products. Tan is effectively saying Intel Foundry Services, IFS, will throw open its doors and play nice with the same software and standards everyone else uses. In practice, that means things like making Intel's process design kits, PDKs, work seamlessly with standard design tools from Synopsys, Cadence, and Siemens EDA, so a chip team can port a design from, say, TSMC's 3 nanometers to Intel 18A without feeling like they've landed on a different planet. It also means embracing industry-standard interfaces and formats, rather than forcing the Intel way on customers. Crucially, Tan has been rebuilding trust with potential customers. He acknowledges that a foundry business is a service business built on the foundational principle of trust. To show commitment, he even literally invested in Intel, purchasing $25 million of Intel stock upon becoming CEO, signaling he has skin in the game for the long haul. Tan's team has been busy unlearning Intel's old habits and learning from TSMC's playbook. At that April 2025 Foundry event, Tan played the role more of a host than a traditional CEO. He handed the stage to the CEOs of Synopsys, Cadence, and Siemens EDA, companies that traditionally might be seen as mere suppliers, to demonstrate that Intel is partnering with them closely. This was a very polymatter-style moment. Imagine the heads of these EDA firms speaking at an Intel event about how they're making sure Intel's process is easy to design for. That sent a clear message. Intel is serious about an open ecosystem approach, not a closed Intel-only stack. Another aspect of Tan's open pitch is standardization and modularity in chip design, specifically chiplets. Let's break that down in simple terms. A chiplet is like a little chip Lego block that can be combined with others to make a full system on chip. Instead of one giant chip that does everything, which is harder to manufacture, you can have several smaller chiplets, maybe one CPU tile, one GPU tile, one cache tile, etc., and connect them together in a package. This approach is increasingly important as chips keep getting more complex and expensive to produce at the smallest transistor sizes. Intel's betting that the future is multi-chip packages where you mix and match chiplets, potentially even chiplets made by different companies or on different processes. But for that to work, everyone needs to agree on standard ways to connect those chiplets. Otherwise, it's like trying to snap together Lego from different sets that don't fit. Enter UCIe, Universal Chiplet Interconnect Express, an open standard that Intel co-developed, along with others like AMD and ARM, for exactly this purpose. UCIe is essentially the USB of chiplets, a common language that chiplets from different sources can use to talk to each other at high speed. Lip-Bu Tan's Intel is heavily promoting UCIe and related standards as part of its ecosystem. Why? Because if Intel can position itself as the hub of an open chiplet ecosystem, it can integrate other companies' technology in its packages and vice versa. For example, an Intel-made compute tile could be packaged alongside a third-party AI accelerator tile, each built in whichever fab is best, but unified by UCIe in one product. This is a very different vision from TSMC's more vertically integrated approach, where TSMC might want to fabricate all the pieces itself. It's almost platform-like. Intel doesn't need to make every chip if it can own the platform that connects all the chips. In effect, Tan is pitching Intel not just as a manufacturer, but as a systems foundry, providing the manufacturing, advanced packaging, and integration to bring multiple pieces together. It's a more open, Lego-like approach versus TSMC's one-stop-shop approach. Tan's open ecosystem philosophy also extends to welcoming any chip architecture or IP into Intel's foundry. This is notable because Intel has long been synonymous with x86 processors. But in the foundry world, you have to be agnostic. Intel has already struck deals to enable ARM IP on its processors, so that customers can build ARM-based chips on Intel 18A, for instance. It's also investing in RISC-V companies and tools, eager to position its fabs as the home for the burgeoning open-source RISC-V architecture community. When Tan says, embrace industrial standards and best design practices, it's a signal that Intel Foundry Services will support whatever design customers want. x86, ARM, RISC-V, custom AI cores, you name it. And make sure the ecosystem, software, IP libraries, verification tools, is in place to support it. This is about lowering every possible barrier for a customer to give Intel a try. In short, Lip-Bu Tan's pitch flips Intel's historical script. Instead of, we're Intel, use our proprietary stuff because it's the best, it's, tell us what you need, we'll make it work, and we'll work with everyone necessary to get there. It's a humbler, more collaborative Intel. The secret weapon Tan is brandishing isn't a new EUV machine or a record-breaking transistor. It's the promise of an ecosystem where Intel plays well with others. But for this promise to make business sense, there has to be a solid economic logic behind it. So next, let's unpack why Intel believes this ecosystem strategy could be the key to a comeback. Why is Intel so fixated on building an ecosystem instead of just pouring all resources into catching up on manufacturing tech? The answer comes down to economics and risk. building and running leading-edge chip fabs is extremely expensive. We're talking $10 to $20 billion per fab for the latest nodes, plus billions more annually in R&D. Intel's previous CEO, Pat Gelsinger, certainly opened the spending spigot. Intel burned through roughly $90 billion from 2021 to 2024 trying to expand and upgrade its fabs. Yet, results lagged, and by late 2024, Intel's board and investors lost patience, leading to Gelsinger's ouster. The lesson was clear. You can't just buy your way back to glory with capital expenditures. You need revenue to justify those giant investments. And to get revenue, Intel needs paying customers for its foundry services. Lots of them, ideally. This is where the ecosystem strategy and economics intertwine. The traditional Intel approach would have been, build the best process technology, then customers will flock to it. But even if Intel's tech becomes competitive, customers won't come automatically. They'd still face high switching costs and trust issues moving from TSMC. By contrast, an ecosystem approach aims to reduce those switching costs and attract customers faster, which is economically crucial. If Intel can show that designing on its process is as easy as designing on TSMC, same tools, familiar IP available, and that they'll have flexibility, like mixing chiplets or choosing different packaging vendors, it lowers the barrier for a customer to give Intel a shot. In effect, Intel is trying to de-risk the decision for potential clients. Come try our fab. You won't be locked in. You can reuse your existing design flows, and you might even integrate our tech with others. And by the way, we'll bend over backwards to help you succeed. Another economic angle is scale and utilization. Leading-edge fabs are profitable only when running near full capacity because the costs are so high. TSMC's ecosystem ensures it has a queue of customers lining up, from smartphone chips to GPUs, keeping its fabs full. Intel, making chips mostly for itself, never had that breadth of customer base. So opening up and partnering widely is the only way to fill its new fabs with diverse orders. Intel's CFO David Zinsner revealed that to break even, Intel's foundry business needs only on the order of low to mid single-digit billions in external revenue. A few big customers could achieve that. But reaching real profitability and return on those tens of billions in investment means scaling much further. Capturing one whale like Apple or Qualcomm could be transformative. Industry analysts point out that just one major customer, one NVIDIA, one Qualcomm, one Apple, could change the whole narrative for Intel's foundry by signaling to the world that Intel's fabs are competitive and open for business. The ecosystem strategy is how Intel hopes to hook such whales. Take Apple's case. Apple currently leverages TSMC's full ecosystem, custom design kits, close engineering collaboration, guaranteed capacity. For Apple to even consider Intel, Intel would need to match or beat that total package. That's not just about transistor specs. It's about confidence that every tool and IP Apple uses will work on Intel's process, that Intel can meet deadlines, and that Apple could still multi-source if needed. By rallying an alliance of EDA toolmakers and IP providers around its processes, Intel signals to big clients, you'll have what you need on day one. Similarly, by promoting open standards like UCIe for chiplets, Intel might appeal to system companies like Apple or system integrators who want flexibility to mix components, essentially saying, if you fab with us, you're not stuck in one closed ecosystem. You can even integrate pieces made elsewhere. We play nice with others. There's also an economic logic in spreading costs and risks. Instead of Intel doing everything in-house, designing all IP, developing all packaging alone, it is partnering with others to shoulder parts of the load. For instance, Intel partnering with memory IP companies or chiplet IP startups means those partners invest their R&D to make blocks for Intel's process, rather than Intel having to develop every component. The recently announced alliance with UMC, United Microelectronics Corp., a Taiwanese foundry specialist in older nodes, is a great example. Intel doesn't need to reinvent 12-nanometer manufacturing on its own when UMC already has expertise there. So Intel and UMC are co-developing a 12-nanometer process platform, expected to have a completed design kit by 2026 and volume production by 2027. This collaborative model lets Intel offer a broader menu, from 12 nanometers to advanced 2-nanometer class tech, by leveraging others' strengths. Economically, it's like sharing the kitchen with another chef to expand your restaurant's menu without mastering every recipe yourself. Moreover, Intel's Grand Coalition strategy could potentially unlock government and industry funding support. The US and Europe have been pushing for more diverse and domestic chip supply chains via the CHIPS Act and similar initiatives, due to geopolitical worries over relying so heavily on TSMC in Taiwan. By positioning itself as the ecosystem for an onshore alternative, including partnerships with American and European firms, Intel can make a persuasive case for subsidies and big anchor customers, like the US Department of Defense or European car makers who need secure chip sources. In fact, Intel's foundry services has a dedicated USMAG alliance for US military, aerospace and government, signaling an intent to serve strategic needs. The economic logic is, if many stakeholders, companies and governments, have a vested interest in Intel's ecosystem, the burden of competing with TSMC doesn't fall on Intel's balance sheet alone. Finally, consider time to market and learning curve. If Intel tried to copy TSMC exactly, focus purely on process tech, it might still trail by years in establishing a track record. But by building a coalition, Intel can accelerate learning. For example, having multiple customers run test chips on Intel 18A helps work out kinks faster and proves out the PDK. Indeed, Intel has several customers lined up building trial chips on its 18A process. Not all will go to production, but this activity generates feedback and confidence if successful. Intel knows that to truly crack TSMC's hold, it must show results, working silicon on time. A broad ecosystem increases the chances that some partner or customer will score a success that Intel can showcase beyond its own internal chip launches. It's essentially casting a wider net, more lottery tickets, hoping one hits a jackpot design that puts Intel Foundry on the map.